Hello everyone, welcome back to Learning Rust series. My name is Rupam. Let's talk about variables. In this video, we are going to explore all the ways you can declare variables in Rust. There is a second part of this video which will be on the data types. You have already seen the main function which had the println macro. Yes, this is a macro, not a function. We'll cover macros later. For now, let's just say this is the way to print something on the console. We'll start with the most basic, an immutable variable. In Rust, variables are immutable by default. It means when we declare a variable and a value is assigned, we cannot change the value of that variable. Let's see that in action. To declare a variable in Rust, we use the keyword let. Now let's run the code and see what it prints. We can see the value of x is printed on the console. Now let's try to reassign the variable with another value. When we try to run the command, we see the error appearing as cannot assign twice to immutable variable x. So this means x is immutable. In the log, we can also see a suggestion. Consider making this binding mutable. We can do this by using the keyword mute. Now let's run the command. We can now see there are no errors and the value of x is 6. There is a warning that is also appearing. This is because the value of x is assigned but was never used before reassigning. In Rust, we can redeclare a variable using the same name. It is called shadowing. Here we have already used the variable name x. Now let's try to assign something else to x. Now let's try to run it. We can see the value of x is now 32. Another useful note, in Rust, if we have any variable unused, we can prefix it with underscore so that it doesn't appear in the warning. In Rust, we can declare constant variables as well by using the keyword const. For constant variables, it is a convention to use capital letters. For now, ignore this colon F32. This is called an annotation for data type. For constant variables, data type annotation is a mandatory thing. Let's try to run this code. We can see the value of pi is now 3.14. We can also perform destructuring by unpacking values from tuples or arrays. We have not covered tuples yet, but we'll cover that in the next video. For now, let's see how to unpack values from tuples. We have a tuple with two values, 12 and 32. Those are unpacked to two variables x and y, and we are trying to print them. We can see the value of x and y are printed as 12 and 32. Destructuring also works with structs as well. We'll cover structs later in the series. If we don't use a variable at all, we can replace it with an underscore. Here you can see only x is printed as 12. Now let's talk about references. Let's say we have a variable declared as x and we assign the value 5 to it. Now what happens is the value of x is saved in the stack. We have the value, the address, and the size of the value. Now when we assign reference of x to y, this is basically referring to the location of x. Now using this reference pointer, we can refer to x. Similarly, we can also have mutable references as well. Now let's head back to the code. Let's declare a variable x with some value. Now let's declare another variable which references to the location of x. Now let's declare another variable z. Which will refer to the value of the reference at y. We'll print the value of z. You can see the value of z is 7 printed. What if we try to change the value of x? In that case, it has to be mutable. So we make the variable x mutable by using the keyword mute. Note that if we make x mutable, we have to refer it as a mutable reference. Now we can perform the increment. Let's try to run the code now. You can see the value of x is 8. We are printing the value of z, but let's try to print the value of x. We are getting some warnings as z is never used, but you can see the value of x is printed as 8. So through the reference, we can perform any calculation as well. We also have static variables in Rust. Statics are like constants, but live globally with static lifetime, which basically means that it lives throughout the lifetime of the program. Static variables are declared outside the functions. It is declared globally. We use the keyword static. Now let's try to run the code. We can see the value is printed as we are learning Rust. Static variables are usually unsafe. That is why when we use them, we have to keep them in an unsafe block. This is because the compiler can't enforce Rust's borrowing rules on a static mutable variable. But you can say this is not a mutable variable, then why to use it here? Yes, this is not mutable in this case, but usually static variables can be mutable. In such a situation, we have to use unsafe blocks. Now if we run the code, we can see the value is still appearing, but with some more warnings that this is an unnecessary unsafe block. Yes, this is because the variable is not mutable, so there is no need for it. But in cases where the variable is mutable, this is very much needed, as the same variable can be called or used in many other threads. This may sound alien to you at this moment, but we'll talk about it when we'll be learning string. If we really need to use mutable static variables, there are certain alternatives present, which are atomic or mutex. These things are pretty advanced, so we'll not cover at this point. There is another type of unsafe variable present in Rust, which are raw pointers. Raw pointers are basically giving you access right to the location. This becomes helpful when we try to handle the memory manually. As we know, Rust uses some rules for pointers, but for raw pointer, Rust doesn't really follow it. Let's try to see that in code. Here also, if we want to dereference the pointer, we need to do it in an unsafe block. If we try to run the code now, I made a mistake with the quotes. Now let's try to run it again. We can see the value of R is 42. This is clearly not our usual Rust reference like %x. So when we really try to use it, it can be used when we try to call a foreign function, like a function that is written in C. Rust is basically saying in this case that you are on your own. So we should be handling raw pointers very carefully. There can be situations where we need to manage our memory manually. In that case also raw pointers help. Since it bypasses borrow checker, it can boost performance in certain cases as well. That's it. That's basically almost all the ways we can declare a variable in Rust. There are two other ways like if let and while let, but that's not really declaring variables in a normal sense. We'll talk about those as well later in the series. Thank you for watching. Join us in the next video where we'll be discussing data types in Rust.